And this getting ready for calculus video, it's going to be a series of three. This is going to be the first one. All of them pertain to radicals. Specifically, we're going to look at how radicals come up in your calculus course. So we're not necessarily doing an overview of all the different properties of radicals. So I put this little disclaimer in here. So basic understanding of radical properties is going to be assumed. So if you want a lesson for that, this would not be the video to watch. This is really just focused on reviewing the ways in which you should prepare for radicals for your upcoming calculus course. So we're going to look mainly for part one. We're going to look at this theorem, which is right here, that says that the nth root of a to the n power is actually just a if n is odd. So for odd roots, and it's the absolute value of a if n is even or even roots. And this is an idea that I do not think a lot of algebra students come out and remember very strongly. So let's review this. When we talk about the nth root of x, in general, we mean the principal real nth root of x, which is the positive root. When we have a negative that is raised to an even power, that is always going to be positive, right? So we can't take a negative number, raise it to an even power, and come out with a number that is negative, right? It's always going to be positive. Now, we can take odd roots of negative numbers, though, right? Or we can, because if you take a negative and raise it to an even power, or sorry, an odd power, then you can come out with a negative. And number four here is also just highlighted to make sure that we have the definition clear of the absolute value of any real number a. We say that it's equal to just a itself for a greater than or equal to zero, or the opposite of a for all a less than zero. So if we come down here, we can see, just to make sure we're all on the same page before we look at some examples. If n is odd, for example, let n be equal to 3. So let's let the base be 2, which would mean you're taking like the cube root of 2 to the third power. Well, 2 to the third power is just 8, and the cube root of 8 is just 2. So this first little part of the theorem is satisfied for this particular example. And so the same thing would be true if you let a be negative 2, still keep n be 3. So here you have negative 2 raised to the third power, so you have the cube root of negative 8. But we can take the cube root of negative 8, because if you take negative 2 and multiply it times itself 3 times, you can get back to a negative number, right? Because it's an odd number of times. So once again, this gives you back the value that we chose for a in the beginning. However, if n is even, for example, here we're going to let n be 2, and let's just choose any value a, let a be 3. Then for this example, you would have the square root of 3 squared, right? There's the square root is really an understood 2 here. So it's still fitting this nth root of a to the n concept. So that's going to be the square root of 9, which is 3. And see, 3 is the same thing as the absolute value of 3. Those are equivalent. But if you let a be negative 3, you're also going to end up with the square root of 9. But we know that gives you 3. However, that's equivalent to the absolute value of negative 3. So this would be the absolute value of a once again. So for this case, it's working in this example. So this is just to illustrate how this theorem is operating. So if we wanted to do some practice and fill in some of these values, let's go straight down the left column. And like we just said, if your power and your root are even, it's going to be the absolute value of the given number. So this is going to be a square root. So this should be the absolute value of minus 7, which is 7. This one would just be -4 itself. Here, it would technically be the absolute value of 2, but that's the same thing as 2. So if you just were to write 2, that would be fine. This one would come out to be -10. This is going to be the absolute value of -3, which is 3. And then finally, this last one would just come out to be 5. So you can see the theorem in action over there. And then these examples, very similar, but we have some variables and not just numbers. So this is important. So if you see the absolute value of x squared, we like to say that that's just x, but officially it is the absolute value of x. So these two are equivalent, where this would just be equal to y. This is going to be the absolute value of a minus 5, right? Because you have an even root. Here we would say the answer is minus b. This one would be the absolute value of 3x. Since 3 is always positive, and we know that, you could even pull that one out and just write it like that. So either of these would then work. And then finally, the last one, we would just say this is minus 2y. Okay, so there is an overview. So practice, and I will see you in the next video, which is going to be part 2 of things you should know about the radicals, getting ready for calculus.